Okay, here's a video about how to solve quadratics using the quadratic formula. Previously, I'm actually going to start with this problem. Previously, we learned how to solve by factoring, where I'd factor my polynomial and then use the zero product property. But what we're going to do today is we're going to use this formula to find the value of x. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know it looks intimidating, but it's actually very simple. So a normal quadratic is written in the form ax squared plus bx plus c. So in this situation, our a is 2, b is negative 7, and c is 3. So with that knowledge, I can just fill in my equation. I know that x equals negative b. Well, if b is negative 7, we're the opposite of negative b, which would be 7, plus or minus the square root of b squared minus 4ac. I'm getting all these numbers from right here, all over 2a. And I always want to simplify this part that's under the radical first. It's called the discriminant. So I'm going to start with that. Negative 7 squared is 49 minus 4 times 2 times 3, which is going to be 24. And that whole thing is going to be over 4. I'm going to keep going. 49 minus 24. 49 minus 24 is 25, so I'm going to keep going. I'm going to zoom out a little bit. The square root of 25 is 5, so x equals 7 plus or minus 5 over 4. Once we're here, I break this into two separate problems because of the plus or minus. I do 7 plus 5 over 4 and 7 minus 5 over 4. 7 plus 5 is 12. 12 divided by 4 is 3. 7 minus 5 is 2. 2 over 4 is 1/2. So, whenever I solve this equation using my quadratic formula, I get the solutions of 3 and 1/2. I can always check that in the calculator by graphing it. If I were to graph 2x squared minus 7x plus 3 and find out where y is equal to 0, I can see that this graph crosses my x-axis at 3 and 1/2, which is exactly what we just found. Now let's look at a different example, one where might not have quite as nice of numbers, and we'll learn how to solve that. So if I start with the quadratic of 4x squared minus 11x plus 1, I know that x equals, I'm going to just copy down my formula real quick. And I know, like I said, I know that looks scary, but you get it memorized in no time. So here, if it's ax squared plus bx plus c is the normal form for a quadratic, then our a here is 4, b is negative 11, and c is 1. So x equals negative b. Well, if b is negative 11, it's the opposite of negative 11. And so b squared is going to be negative 11 squared minus 4ac all over 2a. So let's simplify it a little bit. I've still got my 11 plus or minus. 11 squared is 121 minus 4 times 4 times 1 is just going to be 16. All over 2 times 4 is 8. So if I do 121 minus 16, that leaves me with 105. So x equals 11 plus or minus the square root of 105 over 8. And here's where it's different than the last problem. In the last problem, our discriminant was 25, which is a perfect square, and it was easy to square root. Now it's 105. So since I can't really take the square root of 105, what I'm going to do is I'm just going to leave my answer like this. I could write it as two separate roots. X equals 11 plus the square root of 105 over 8, and x equals 11 minus the square root of 105 over 8. But those are the solutions to this equation when I use the quadratic formula.